All right. Hi guys and girls, this is Mr. Dice, and I'm going over for both mine and Mrs. Fruits' calculus courses. You're going to see the area of a region between two curves on your IU ACP exam. So I wanted to give you an example and show you, work one out for you guys. You're going to see this on your test, and it's a very straightforward question on the test, so I'm going to give you a very straightforward example. Real quick though, we need to understand what we're talking about when we say area between two curves. So if you look at this shaded pink region here, we're trying to find the area between the curvatures f of x and g of x from a to b. And so here's how we kind of discover this. If I just said the integral from a to b of my top function f of x, it would be all this shaded area. If I said the integral from a to b again of this bottom function, which is g of x, which would be this shaded area. So I can find the shaded area here by taking all of this minus this, and the result is the area between the two curves. So that's what we mean with the integral from a to b of the upper minus the lower. So I'm talking about the upper curvature minus the lower curvature. Okay? And a lot of times we'll use this representative rectangle. It just makes, what we're doing is we're going to take that top minus the bottom. And we didn't get to all this year. We would also go from a right minus a left, and then we would find volume and rotate it. So, but for what we need on the IU exam, this is sufficient. Okay, so there's our function. It would be the top minus the bottom, the upper curve minus the lower curve. And I'm going to give you an example. And I went ahead and already have the visual for you guys. So I said, find the area of the region bounded by the graph of these two functions. But you won't be given the graph. So let's understand, we need to know where these two graphs cross that are bounded. That's our keyword, bounded by these two regions. We need to know where they intersect. And they intersect where the two functions are equal to each other. So when does 2 minus x squared equal x? And I'm going to go ahead and I'm going to add the x squared over, subtract x, so it becomes 0 equals what? Positive x squared, positive x minus 2. And fortunately on this example, I can solve by factoring. So 0 equals, that'll factor into what? X plus 2 and x minus 1. So I get the points of intersection at -2 and x equals 1. Now I'm confident every one of you could have graphed that parabola that opens down with a y-intercept at 2 and that straight line with a y-intercept of 0 and a slope of 1. So here's my graph, and if you notice what we've found here, and you'll have to do this, is the points of intersection are from -2 to 1. So to find the area between this curvature, I'm going to take the integral from -2 to 1 of my upper curve, which is the parabola, 2 minus x squared, minus the lower function. Now you got to be careful here. Minus the entire function. In this case, it's just simply x. But if it had been minus a binomial or trinomial, you need to make sure you distribute that negative through the function. So it'd be minus x. And then don't forget, in respect to x, so it'd be d of x. Okay? So now I'm going to take the antiderivative, which gives me 2x minus 1/3 x cubed minus 1/2 x squared from -2 to 1. So I'm going to take my fundamental theorem of calculus, my f of 1 minus my capital F of -2. So I'm going to plug in 1. I'm going to solve it. So when I plug in 1, that's 2 minus 1/3 minus 1/2. So if I plugged in 1, 2 minus 1/3 minus 1/2. So I'll write it out for you guys. It's 2 minus a third minus a half. If you want, common denominator 6, so that's what, 12/6 minus what, 2/6 minus 3/6, which gives me 7/6 minus, and now I'm going to plug in my -2, and this will be a little bit more complex now. So we're going to plug in -2. 2 times -2 would be, and then I'm going to write it like this: -4, -2 times, I'm trying to do it in my head here, and I'm going to mess up in my, so -2 cubed would be -8 times -1/3 would be +8/3. I don't have people in class holding me accountable here. I very likely can mess something up. And then -2 squared would be 4/2, so -2. I'm going to put those all over 1. So again, I'm going to take 7/6 minus whatever I get here. My common denominator looks like it's a 3. So it'd be what? -12/3 plus 8/3 minus what? 6/3. So -12 plus 8 is -4 minus 6 would be -10/3. And then plus a negative, and that becomes common denominator of 6, 20/6. So 7/6 plus 26 would give me 27/6. All right. Well, I hope this helped, guys. And we'll see you, Ms. Fruits, and I will see you guys for your IU exam.